Welcome back, everybody. Today we're going to talk about how forces influence motion. This boy throws the ball and catches the ball with his glove to influence the motion of the ball. Forces from the air, from the water, and the rope are moving him on this tube. For us to understand the motion of objects, we have to understand the forces that are causing those motions. Here's something for you to try. Take a pencil or have a lab partner hold a pencil and then put a ring magnet on there. Then put another ring magnet on facing the same direction as the first magnet. And watch how that magnet moves. Think about the forces that cause that magnet to move. Now, let's add one more ring magnet facing the same direction. Notice the forces that make that magnet move and what happens when those forces get balanced out. Suppose you're trying to move a piece of heavy furniture like I'm trying to move this desk by pushing. Maybe if I invited a friend, I wouldn't have to push as hard. The combination of all of the forces acting on an object is the net force. When I push with a force of 100 newtons to the left against a desk that has 300 newtons of static force, it doesn't move. But when Jaylee comes in and adds her 200 newtons of force, we overcome that 300 newtons. In this situation, we are pushing equally toward each other. Balanced forces occur when the net force on an object is equal to 0. Unbalanced forces occur when the net force on an object is not 0. Newton's first law of motion states that balanced forces acting on an object will not cause the object to accelerate. Let's take a little second to talk about acceleration. Acceleration is any change in velocity. But wait, what does that mean? Well, velocity is very much like speed. Speed is how far you are going in a given amount of time, where velocity is your speed and a given direction. So that means acceleration is a change in speed, a change in direction, or both a change in speed and direction. So what that tells us about what Isaac Newton was saying is that Isaac Newton said that when balanced forces act on an object that is in motion, that object will continue to go at the same speed in a straight line. But if balanced forces are acting on an object that is not in motion, that object won't move. That brings us to inertia. Inertia is the resistance to change in motion. What inertia means is that an object will resist change. If it's in motion, it will want to stay moving in a straight line unless acted upon by an outside force. But an object that's at rest will remain at rest unless acted upon by an unbalanced force. Here to demonstrate inertia is our little Lego buddy. We'll call him Jim. Jim's going to ride on top of this wind-up car. Here he goes. What happens to Jim when the car stops? Let's see that again, only slower. Jim comes in, he's riding on the car, which means he doesn't want to change his direction or speed. When the car stops, Jim continues to move because there's nothing holding him to the car. Inertia is the reason car manufacturers use seat belts. Let's see what happens when we rubber band Jim to the vehicle. All safe and ready to go. This time, when the vehicle stops, Jim is connected to the vehicle and he doesn't go. Another example of inertia is shown by Goldie here. Goldie is at rest, and without forces acting on him, Goldie will not move at all. Look, it's been 6 seconds. He's not going anywhere. So if objects are in motion and they want to stay in motion, what makes them stop? Remember in our last video when I rolled the tennis ball? What made the tennis ball stop is friction. Remember we talked about friction? when two surfaces make contact with each other and it stops motion? On Earth, because we have an atmosphere and air pressure exists, we can never get rid of friction, but we can reduce it. That's it, folks. It's time for your favorite section of the show, where we wind everything back. We started out by talking about how forces can make an object move. And the combination of all of the forces is the net force. If the net force acting on an object is zero, the forces are balanced and the object will not change velocity. Newton's first law of motion states that if an object is at rest, it'll stay at rest, and if an object is in motion, it'll continue moving in a straight line at the same speed unless acted upon by an unbalanced force. And inertia is a resistance to change in motion. Lastly, we learned that all things on Earth will come to a stop because of friction. Thank you for watching, and we'll see you next time.